Hello. So we're going to be talking about Git, and I've had a bit of a time trying to remember how to set this up on Windows, but I figured it out. I'll tell you how to do it now. So when you open up VS Code, by the way, it looks gross now. They did some update, and I really don't like how this looks. Like when you open a file, it's got this. Oh, it's horrid. Anyway, on the left-hand side, you'll have a source control tab, and if you don't have Git installed on your system, here it will say something like install Git. And when you click that, it'll take you to this page where you can click this link here, download Git for Windows, and then run through the installer. You can keep all the default options. They are harmless and they are fine for anyone new to Git. It's just like if people have opinionated use cases, or they're used to using it in a certain way which isn't out of the box because they've been using it for a while and the defaults have changed, then they can change them, but just keep it out of the box if you don't know what you're doing. And then that will give you access to, when you open up a terminal, on the right hand side where there's pluses, you can launch a git bash session. And if you ran the command git, you'll see that it comes up with lots of options because Git is installed. That's the Git CLI command line interface tool. However, while we have Git, we now need the GitHub tool, because GitHub is a separate platform that uses the Git protocol. There are a few different like Git repository platforms like this, like GitLab is another one. They all work the same because they all use Git under the hub, but they are separate entities. So GitHub have a command line interface tool called GH. I'm assuming it's short for GitHub, and you can use that to log in. And the reason you need this tool separately is the Git CLI tool, which you install first, is so you can work with the Git protocol. But the GitHub CLI tool is so that when you use the Git protocol, GitHub knows who you are. So to install this, you want to go to GitHub/CLI/CLI. So that's Charlie Lima India. So CLI/CLI. And this is the CLI tool. If you scroll down, it will say that for Windows, you can install it using winget. So if you click that, it'll take you to this page, and you can use this command here. So just click to copy it, paste it in your terminal, and Windows will use this thing called winget, which is another CLI tool that just exists in Windows for fetching software. It will use that to install the GH command line tool. Once GH is installed, restart your VS Code, and you should then be able to come back in, type GH, and you should see it say like lots of options about it. If it says GH is not recognized, restart your computer. If it still says it's not recognized, you just want to make sure you're using the git bash terminal. You have installed it via this command, and it should be there. For that point, it should just work. So now that we have GH, we want to run GH auth login. So GH auth login. Where do you use GitHub? We use github.com. We're going to use HTTPS, and we are going to authenticate with our credentials. We're going to type Y for yes. We're going to log in with our web browser, and we want to copy our one-time code. So if you just highlight it and right-click, the highlight will go away, but that means it's been copied to your clipboard. So then press enter again. This will open your browser. I'm already logged in into my GitHub account, so I can just hit continue there, paste my code, and I can authorize it. And that's it. You are all set, it says. Hooray. So in theory, if I do this, it still says I don't have permission. Hang on. Git remote. Nope. Push set. Alright. Wait, that's fine. Either way, once you've done that, you should be off to the races. I'm just going to restart my terminal or my session just to make sure that's fine. So what I'm also going to do is, if I go to my desktop. Okay. So what I've done is I've created a GitHub repository here called Git Demo, and I'm going to use that to show you it today. So in order to get started, because I opened GitHub, I clicked on this little plus at the top to create new. I created a public repository and I called it Git Demo, and that's it. And it gives me this screen. You won't have to do any of this if you're just working with existing code, but this is just how it works. So quick setup. All you have to do is HTTPS. You can copy this this link here. That's the link for this. And then you can do git clone and then that link. And it says cloning into Git demo. And when you run clone, that just means you are pulling something down for the first time from a remote source, such as GitHub. So if I now open folder, go to my desktop, and I open Git demo, this is the folder that just got cloned. You'll see there's an invisible folder called Git. More on that later. So if I open this folder, and restricted mode is intended for safe browsing, trust this folder to enable more features. Because this was downloaded from a remote source, VS Code is telling me to be careful, so I'm going to click manage, and I'm going to say that I trust this folder because I know where it came from. This is important because not all code online is safe, especially in Git repositories. People can put whatever they want in there, including malicious code. So you shouldn't just blindly clone things down, but because this belongs to me, I know that it's safe. I mean, it's blank, so it's very safe. So now we have our Git repository open. If I click on the source control tab, you'll see here that there's no history, there's no changes, and there's no files in here. But you will remember that there was an invisible folder called .git in this directory. So if I do ls, which is lists the current folder, there's nothing there. But if I do ls/a, or is it? I don't know the commands actually for Windows. How do you view invisible folders? I don't know. It's fine. I'll do it in here. So if I go to here, you'll see we have this Git folder. If I open it, so this actually exists within where I am in VS Code, but it's hidden, which is what the dot at the beginning means. And you'll see here that we have lots of details, and this is how VS Code and Git knows what the current folder is linked to online. We don't actually need to understand any of this. This is fine. I mean, you could open like the description if you wanted to, or the config rather, and just kind of see what it says. And you can see here that it's pointing to that URL, and that's fine. But the point is that this is how we know that it's initialized to use Git. So over here, if I do a new file, I'm going to call it readme.md, which is markdown. I'm going to say git demo. So this is literally just a text file. It's the same as doing .txt, but .md means that it uses markdown, which is like a way for us to make things look visually different. Because like you can do like, you see how like using different characters makes it display differently over here? That's what markdown is, and it's used for the readmes that you get in these repositories. So I'm just going to put it back to that. And now I've got a file. If I go over to source control, this is the Git magic. You'll see here that it says changes, and we've got this new readme.md file. Ooh. And if I go over to the browser and I refresh, you'll see there's nothing here because it's not been committed or pushed. So I can right-click and stage my changes. I'll explain all these steps later. I'm just going to do one push to begin with. And then I can put a commit message, which is I'm going to say add readme.md file. Then I can commit it. And then push branch, and that means push my changes to the remote. And you'll see down here now that under changes we have that where it says add readme.md file. So that's the change I just made. And if I click this to expand it, I can see here that what changed is I added this file. That's what the A there means, add, and when I click it, it shows the file. I can collapse those, and now if I go over to GitHub and I refresh it, now we're talking. So whenever you have a readme.md file, GitHub will output it nicely here. And I can see that that's me, made this commit, add readme.md. I did it now, and there's only one commit on the repository. Sorry, repo's repository. So let's make another change. I'm going to go back to the README, and I'm going to say this is an introduction to using Git. I'm going to save that. And now, once again, I'm going to come over to my source control tab, and when I click it, instead of this used to have an A on it, like what you see here, it says A because the file was added, but now it has M because this file was modified. And if you click it, it will show you a before and after. So this is so on the left-hand side, like the before, this is at the start of the commit that you have in your machine. So like this is the state it's in right here. And now this is the new state that we've taken it to. And this is kind of the beauty of Git, is if you think when you're like learning how to code and you get in the habit of making a file, right? And it's like my thing.py, and then you make a better version and you're like, oh, I don't want to delete that, so I'm going to make my thing 2.py. And then all of a sudden, you've got like 30 of these, and you've got one called final, and then you've got final 2 because you realize the final one sucked. And this is why Git's just great. So what I'm going to do is I'm going to stage these changes, and that just means that I'm happy with my changes, and I'm it's like in the weakest link, I'm like banking it. I'm like saying, right, I like that. Let's call that good. And I'm going to enter a commit message. I'm going to say update. This is just like, people tend to have like their own patterns for how they do these commit messages. You want to keep them useful if you can. I tend to use, and this is something I learned from work, I would either put like add, delete, or fix, or update, things like that. So update, or I could do add, intro line to readme.md. And then commit and sync, which essentially means push. I'm going to push my local changes up and have the remote repository match my computer. So you see here, we've got 2 commits now. So we've got the original one, where we added the file, and you'll see here it still knows that I added it and this is what it looked like. And then we have where we added the intro line, and here we modified the file, and if I click that, it shows the before and after. And if I go over to the browser, it now has this. This is an introduction to using Git. And you'll see we've got 2 commits. Well, if I click 2 commits, you'll see the same thing here. And going back to what I was saying about how we don't have to have like my file 2, my file 3. Let's say I've done some work and I realized 2 weeks later that I hated this current version, or I deleted something that was really important and I don't remember how I did it, and I got rid of it, and I'm like, no. Well, Git preserves everything. So not only can I see these messages and I can see what changes in each step. It's like if I was to open this, I'm going to open it in a new tab, just click the title. It shows me like what changes. It says plus. So these 2 lines got added. That's what this means here as well. 2 blue pluses, that means 2 lines added. Right, so I can see what changes. But I can go over to the right-hand side and I can click browse repository at this point. And if I click that, this is what it looked like in its old state. So I can go in here and it's like, whoa, I can see exactly what it looked like at that time. So you do not lose progress. So it's just in terms of, it really covers your tracks. So what are the different actions that we can actually take while using Git? We have, well, there are a few terms to be familiar with. So we have pulling. So if you were to pull something, so okay, well, we have cloning. Well, first we have cloning. So cloning is, I've got a brand new system which I want the code to be on. So that's when you clone it. So when you clone a remote repository, it's because you've got a brand new system or you're just a different computer. The code is not currently on it. You want the code to be on it. So you will go to GitHub. You can click this little code button, grab this link, and then you can run git clone and then the link, and it will clone it from that location. And then we have pull. Okay, and what pull means is, let's say, I can demo this actually. So this is on GitHub. I can actually edit files in GitHub, which is quite cool. So if I open the README and I go edit this file, I made this change via my browser. Commit changes, update README, it just kind of automatically generates that. I'm just going to change it to meet my normal syntax via browser. So commit changes. Aha, so that's now what it looks like. So if I go back to the main bit of the repository, you can see we've got 3 commits. It looks like this now. If I open the commits, those are all 3. But you'll see that on my computer, it doesn't look like that yet. So what I'm going to do is I'm going to just cut those to my clipboard so I can paste them back in a minute. If I go over to source control and I hit this little refresh just to check our files, you see we've got no changes, but down here we've only got our 2 commits. Well, that's where git pull comes in. So you have 2 ways of doing this. You can go to the command line and type git pull, or you can use these 3 dots and you can go pull here. I'm going to use the command line just because that's what I'm used to. But when you run pull, what it does is it goes to the remote and it checks the commits. And it uses these little hashes to know what commit is what. So my computer will have sent a request to this page, essentially. Not really, but think of it that way. And it says, right, I have, at the time, I had these 2 commits. So it says my latest commit is this one, 09685EA. And then GitHub has said, well, I've got that, but I've also got BE13 blah, 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 blah. And then because we know that GitHub has all of mine plus 1 more that came after, which was built, or it was built on top of that previous commit, because you have to think about like incremental changes. So this was made from that commit. It tells my computer that, and my computer goes, well, that means that I need this one, and then we're up to date. So it fetches it. And you can see that was my change I made. So we now have all 3 commits, and we're all synced up again. So that's what pulling is. So pulling is fetching changes from the remote. The remote is basically the remote source. So in this context, it's this repository. So we have pull, and then we have push. And push is to, well, it pushes, or let's say we have sort of saving our changes to the remote. So that's the reverse of what we did with pulling, right? So let's say here that when I've made any of these commits, and I type my commit message, and then I push it up, it will tell the remote source here. It will say, hey, I've got a brand new commit for you. It's got this hash, so it's got like a new ID, and it says, and it will tell it that I made it from this hash. So if I started here at BE13883, I made some changes, I did the whole commit, type a message, and I hit push. Then when it comes over to here, GitHub will receive it, and it will go, right, well, I've got that one that you started at, and I'm going to I know exactly where your changes go. They go above my most recent one. So you're pushing. So we can push and we can pull. Then we have commit. Well, we have staging and committing, which I'm going to group. So when we make a change, so if I save this file and then I can refresh it, or sometimes it picks it up on its own, and you see that we have the change over here. We can click it to see like the before and after. So we have staging, which is us saying, yeah, we like that. And you'll see that it kind of like it pulls on both sides. Staging is kind of like it's kind of like a way of saving your progress without pushing up right now, because what I could do is I've staged these, so I said that I'm happy with that, but I could keep working So I could say blah, blah, save that. And then you'll see that I have my staged change, which goes from what it looks like originally to where I staged it. But then I have my new changes, which it goes, this is where it was. So this is where it was when I staged it, and this is where it is now. So if I'm working on something and I don't want to push it up just yet, but I want to kind of save where I'm up to, if you will, because I like where it is, and I just don't know how to do the next bit, I can stage some, and then I can restage my changes again to kind of layer them on top and get ready to put my final commit together. So I'm not going to group these together. So staging is like preserving where you're up to in your current changes. And then we have commit. And commit is, well, it's committing to making your changes for done in preparation. I don't know how to spell preparation off the top of my head. In preparation of pushing the changes. Then we have committing. So once we've got something staged, we're then ready to commit to it. Because I can review my stage changes here and I can say, yep, I love that. I think that's great. That's exactly what I want. So here I'm actually gonna save this, refresh, stage that, and there we go. We've got our commands listed out. I'm also gonna do like that. Just change that. make it nice. Okay, so those are our changes before, after. So when you're committing it, you're saying, right, done. That's my new commit. Now it's important to note that these here, you'll see as it says commits. These are individual commits. So you don't have to push every single commit that you make at the same time. So if I commit this, now I'm going to say add list of common Git commands in README, and I commit it, you'll see that it's now down here. Add list of common Git commands. And it's got its own hash ID thing. So if I hover over it, somehow, oh, it's that one, yeah, hover over it, 4A89, blah, blah, blah. And it's not on here because I've not pushed it up. I haven't pushed it yet. Well, I could continue to make changes. Foobar. I don't have anything to actually say, to actually write in this one, but I'll just put foobar. If I come over here, and then you can see I've got my changes. So before, after, we know how this works now. Stage it, add foobar to README, commit. And you can see now we've got two, that change and that change. And they're both here. They're on my local system. This now says sync changes to. And when I hover over it, it says push 2 commits to origin/main. And over here, we still only have the 3. That's because we can do git push, or we can click that sync button. And now it's going to put both up at the same time. And they will come up here exactly how they were locally. So those are the basics of Git. So now you can probably see to yourself the value as an individual in using Git, because it means that you can preserve your code in all the different states that it's existed in, and you won't lose progress. Well, the beauty of it as well is that you can collaborate with people really effectively. Because let's say that there are 2 of us working on a project. We can both work from the same source code in that same state simultaneously without stepping on each other's toes too much. And the reason is if we both make a change, and we both make a change, GitHub will let us resolve conflicts. So let me set up a situation where this would happen. Okay, so in this README file, on the website, because I need to edit in 2 places to do this as like an example. So I'm going to edit this file in here, and I'm going to add an no, actually no, you know what? I'm going to delete something. What am I going to delete? I'm going to delete that line up there. So I've deleted that I made this change via my browser. I'm going to commit that. Go remove redundant text from README. Commit. And I'll go back to the main thing. You see that's the latest commit. And if I go to the commits, it's right there. But again, the cool thing is I could open up the old version. So I clicked this in a new tab, and I can still see it there. Like, even though I deleted it from the current version, it's still there. I don't lose anything because Git is great. So while this was happening, let's pretend person 1's just made this change to the README file. Well, person 2, which is Muggins over here, I actually like this line, and I wanted to add to it. I made this change to my browser. I'm so cool. This is really getting out of hand, but I'm going to save that. Come over to my tab, and you'll see here, we have no idea that someone else changed that line. Well, if I stage it, I'm going to say update readme.md, that'll do, and I commit. Well, what's going to happen here? Because we have what's called a conflict, because the remote repository has that line deleted. So the remote repository, someone at this commit hash, for the one beginning 49, they then deleted it and committed it to the repository. But over here, where at command hash 49, they went and they added to that. So if I try to sync my changes or push them, here we go. It says there are merge conflicts. And that's because two people have made a change and GitHub doesn't know how to resolve it. So it's saying, look, these two lines were changed. This was changed since you made your change. Which one do I want to keep? So here it says merge changes on the left now. And when you click on it, it gives you a couple of options. So you can see that what I did is here, the current change. So the current change that I made that I'm pushing up is, I said, I made this change via my browser. But the incoming change, and it looks a little bit weird because what it's actually doing is removing the line. But the incoming change is that the line is gone. And if, let's say, two people edited the same line, but they just changed the text slightly, then this text would be like under here in blue, saying whatever they changed it to as well. So I can now choose, do I want to accept the current change, the incoming change, both changes, that can be appropriate sometimes, or just compare changes and kind of figure it out myself. Well, in this case, I would like to keep mine. So I'm going to click accept current change. And what we're doing is now we're telling Git, look, I know that someone else has deleted that line, but my changes require it, and I've reviewed that new state of the code, and I've decided it's still appropriate to keep mine in. But I could just as easily have gone, yeah, they deleted it, that's actually better, so we'll keep that. So what I do there is, yeah, I click accept current, I then save the file, so Control S or file save, and then we have to restage and commit again. So right click, stage it, continue, and now we're ready. But this is what's interesting. You look over here. So you see there's these like pathways have opened up. So this tells us exactly what happened. So we have this commit here where I added the foobar. And then since then, somebody came in, and that's this commit. Someone came in and they did this. This is me, I added I'm so cool. But at the same time, somebody deleted that. So that's why, so these two are kind of, it shows how this was a diverted branch, because these are like timelines, right? So it branched off here, because somebody in one version of reality, they deleted that thing. And in another version of reality, they added this text. So you see how like that dot is on the left, that dot's on the right. That shows that these two happened in parallel. And then there's a new commit here, which is merging those changes. So if I click on this thing there, was it there? Oh, it's this one. Then you'll see the outgoing change now is, in order to consolidate these two parallel timelines into the same dot, I decided which one I want to keep. And I'm now going to sync that, aka push. That's set in stone. Everyone can see exactly what happened. We know what happened and when. And if I refresh over here, you'll see that, yeah, we removed the redundant text. We updated it locally. And then we have the separate commit where I was asked to resolve the conflict and decide which one I want to keep. And again, I can see what everything looked like at any stage in all of this by clicking these little browse repository thing, and I can see it looked like this at this time, and no work is ever lost. And that is kind of the power of a Git commit. The final thing, this is the final thing, which is important to know, is branches. So if I click up here, it says main, we are on the main branch. Now, if you think about how we had that parallel timeline analogy going on here with the left, we can do this intentionally. Because let's say that we're working on a very complicated project with several people working on it or whatever it is. And there are two people working on two different features at the same time. And they're complicated features. They don't want to do everything in one commit. You know, they need to like do several commits, and then they want someone to review their changes before it gets put in amongst the rest of the code. Well, they would create a brand new branch, and it's like a branch off a tree. If you think that this is the main branch, and then when we want to make a new branch, we just branch off to the side, and it's exactly as this kind of visualizes here. So I'm going to do that. So in order to make a new branch, I need a new command, which is going to be, I'm just going to delete that foobar, which is going to be checkout. Creating a new branch, and then we have switching between branches. Okay. So in my terminal, I'm going to do git checkout -b. And -b means that we are checking out to a new branch. So git checkout b, and I'm going to call it example. Switched to new branch called example. You can also do this up here, I think. You could do like checkout to, and then you can do it that way where you can create a new branch if you want to do it all visually. So git checkout -b example. So we're now on a new branch called example. And on the bottom left here, you'll see this is our branch. So if I click this, it kind of shows these branches at the top where we've got example and main. So we're at example. And I can publish the new branch. So I'm going to do that. I'm going to just publish the new branch real quick. There's no changes on it. It should just be the same. Because I have changed this file, but I've not saved it or committed it. So if I go over to GitHub and I refresh the page and I click this, you'll see that we now have main and example. So let's say in the example branch, I'm just going to do another update to readme. Update readme.md with branching commands. So I'm going to commit that up. And I've done this in the context of the example branch. So I'm on the example branch. I've put that commit on there. So if I come over to GitHub, it does say example had recent pushes 50 seconds ago. Well, if I refresh my page, you'll see that the most recent commit is still the merge that we resolved. It's not this one that I've committed over here. And the reason is we're on the main branch. So let's go over to the example branch. And on the example branch, there it is, update readme with branching commands. And just like on the main branch, I'm going to open this in a new tab. You can see we've got the full history of commits. I can even swap tabs on here to see what the commits are and everything. And it says this branch is one commit ahead of main. So let's say that I wanted to keep doing work. I'm not going to because it's just going to, I don't think it adds a lot, but I could do several commits on here on this branch. And then in main, I could do several commits. It doesn't matter. We can completely diverge in terms of where the code is going. We can make loads of changes in parallel. And the reason we want a separate branch is because if we're working on a complicated feature, we want to make sure it's ready to go before it goes into the main bit of code. Because if there's a bug, we want it to be fixed before it then goes into main and other people start working on it, blah, 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 or it gets pushed to a live situation. So in GitHub now, I can do compare and pull request. So I can create a pull request, which essentially says, it's a way of saying that I've done all these changes on this branch, and I think it's now ready to be merged into a different branch. So I want, in this example, the example branch, as depicted by this arrow, to get merged into main. And all that would do is it would work like committing to main. So you would normally type out a message to say what your branch does. So if it's a brand new feature, you would explain the feature, you would explain how it works and maybe give a demo and stuff. And down here, it'll show you all the commits that are going to be brought in as a part of this. There's only one here, but and then it also shows you like the actual changes that are all going to come in, and you can click create pull request. So now we've got a pull request. So if I go back over to code, you'll see that the main branch is still unaltered. But there are 2 branches still, and we have 1 pull request. And that pull request is someone saying, my branch is ready, or I think it's ready to be merged in. So typically one person would make a pull request. Another person would maybe review the code first. They can like look at the file changes, and they can even go on here and they can like click a little plus and leave comments and be like, hey, you should maybe try this instead, or this wouldn't work, or I like this. You can review your code that way. And then when we're ready and we know that it's going to be good, we're going to merge the pull request. And when we merge it, it's going to consolidate those two branches, just like we did with these on the left-hand side here with these 2 divergent like commits. We can merge these 2 branches together and consolidate them. So I'm going to merge that pull request. I can set a commit message. I'm just going to let it use the automatically generated one. And it says your pull request has been successfully merged and closed. So now if I go back over to code, you'll see that the latest history is that we have merged our pull request. We've merged that pull request from example, and this will now represent the latest version of what it looks like. For some reason, oh yeah, it does, because it just occurred to me these are just not on new lines. But you see how we've got switching between branches. For some reason, it's showing them as all separate line, sorry, the same line. That's a markdown thing, but it does have all of our content on here. And that's pretty much it. So if I go to commits here, we can see the whole history of what happened. That example branch will still exist. Branches, you can set them to get automatically deleted when they're merged. I tend to like doing that, but you don't have to. But you would typically use a branch once and then never use it again. So I'm going to go over to the example branch here and delete it now because it served its purpose. And any content on it would be stale. So that branch is now gone. So that's everything. That is actually everything that I have to show you. In order to get started using Git yourself, go to your GitHub account, click create a new repository, clone it locally, and then just start using it. The important thing to be aware of with Git is while it is really secure in terms of how it preserves your work, it's not flawless, and user error can still result in losing code. For example, you can do something called a force push. So when you do a git push, you can use a -F for Freddy to force your commit. And what that would mean is if I was to locally delete all of these commits and delete all my code and do a force push, GitHub will, instead of trying to resolve things and say, well, I've got these that you're missing, so maybe you're out of date and you need to update your code first, it will just go, right, you're saying force, that means that what you've got is correct. I will just use what you have, and it will delete everything to match, or it will just match what you provide it. So you can still lose work. So if you don't know what you're doing, or if you don't know what a command does, don't use it. Because if you go online, like say if you accidentally commit something, you want to undo it or whatever, you can, but it takes a bit of know-how to do it safely. So you might end up Googling it and someone will say, do this fancy command thing, and then suddenly you could lose work. So be really careful. But if used in a way that I've just shown you, only using the commands that I have shown you, you will find that your folders will be a lot cleaner. You will have a clear revision history for all the work you do, and you can sleep soundly and collaborate with people a lot easier. But that's pretty much everything. So hopefully that was all clear and not too rushed, and also not too long. But yeah, I'm going to leave it there. So, ta-ra.